everyone. This week we'll learn about Cassandra database. So relational databases are the most commonly used type of database. They work well with applications designed for a wide range of uses, from business operations to science research. Many web applications use popular relational databases like MySQL and PostgreSQL. Although relational databases work well in many cases, some applications have requirements that are difficult to meet with the relational databases. For example, some applications must write large volumes of data quickly, while other applications require extremely fast query response times. In addition to this, some applications need to have high availability. Relational databases can achieve high read and write rates, but some of the features of relational databases make this difficult. For example, relational databases ensure that read and write operations are consistent so that all users see the latest correct version of data. Keeping track of multiple users reading and writing data and ensuring that data is consistent adds overhead to relational database operations. Now, if you're willing to work with a database that doesn't guarantee the same level of consistency, you can have significantly faster database operations. NoSQL databases are non-relational databases. As the name implies, they do not use SQL for defining and manipulating data, but the differences go deeper than that. Let's look at Cassandra, a wide column NoSQL database. Cassandra has many similarities to relational databases. Both use tables as a basic data structure. Tables are made of columns that store attributes. Cassandra uses data types that would be familiar to a relational database developer, such as integer, varchar, and date. Cassandra tables have primary keys, which uniquely identify rows in a table. Primary keys are used to access data in Cassandra. Primary keys are not enough to find rows in Cassandra because Cassandra is designed to run on a cluster of servers. There is no single server in a highly available Cassandra database. Now we can run Cassandra on a single machine, and developers do this regularly. But production databases are best run on clusters of multiple servers. To enable fast access to rows within tables that span multiple servers, Cassandra tables use two additional kinds of keys. The first one is a partition key, which is used to determine which node in the cluster to store a row in. The second one is clustering column. A clustering column defines the order in which rows are stored. Also, it is worth noting that servers in a Cassandra cluster are called nodes. We'll follow that convention in this slide. Cassandra has a query language called CQL, which stands for Cassandra Query Language. It is similar to SQL, but has more restrictions, as we will see. It uses a select statement for querying to retrieve all columns about an employee with an employee ID equal to 8928. We could use a statement such as this: select star from employees table where employee ID is equal to 8928. Cassandra has other commands similar to SQL commands like these that are used to define data structures like tables and indexes and to modify data like the update command. Cassandra does not have a fixed schema. Some rows may have different columns than other rows. For example, in the employee table, managers may have a column called number of employees managed, while non-managers do not have that column. Another big difference with relational databases is that Cassandra is an eventually consistent database. That means there may be times, usually quite brief periods of time, where replicas of a row have different versions of the data. This is because Cassandra keeps multiple copies of data on different nodes. In case a node fails, user can still get their data from a replica on another node. Even for databases designed for fast operations, it can take some period of time before all copies are updated. In that case, a user might read an old version of data. This difference in the copies of data is known as an inconsistency. Eventually, the inconsistency will be corrected. Throughout this course, we will see examples of Cassandra features that sound similar to relational database features, but in fact are implemented differently. It is important to keep these differences in mind because they influence how we build data models for Cassandra. In Cassandra, the top level data structure is the key space. This is like a schema in relational databases. Key spaces are logical containers for tables, indexes, and other data structures. Now, in addition to providing a namespace for organizing data, the key space has attributes that control some important features of Cassandra. When you define a key space, you also define a replication strategy. This determines how replicas of data are made. Remember, replicas are an important high availability feature of Cassandra. If a node fails, the data on the failed node can still be accessed from one of its replicas. There are two kinds of replication strategies. The simple replication strategy is used to set a number of replicas when all nodes will be in a single data center. The network topology strategy is used to set a number of replicas when nodes will be distributed in multiple data centers. In both cases, the replica strategy takes number of replicas as a parameter. For example, this command on your screen creates a key space called perf monitor. We'll use this for storing data about application performance monitoring. So this command has the create key space phrase, followed by the namespace of the key space. In this case, perf monitor, followed by the keyword with, and then a replication specification, which in this case includes two attributes, the class, which in this case is simple strategy, and then the replication factor, which in this case we are using 3. So we have 3 replicas. So once we have our key space defined, we can define a table using the create table command. We will need to define our table name and a set of columns. Let's assume we want to keep a track of performance monitoring statistics in a Cassandra table, which we'll call app instance. We will include columns for attributes about each application instance that we would like to track. In this example, let's track several attributes, including the application's name, the IDs of its process, and the host on which it runs, the operating system priority, as well as some measures such as CPU time and the number of I/O operations. Now that we know the attributes we want to maintain, we can create a table with the following command. Create table takes a list of attribute or columns followed by a data type such as text and int. It also takes a primary clause to define which columns to use as the primary key. Now in this case, create table is followed by the name of the table, app instance, as well as a list of column names, followed by data types, and its closes with the primary key specification. Columns can be either a single value of a group of multiple values called collections. Single values are defined with data types such as int for integers, text for strings of text, float for floating point numbers, timestamps for points in time, date obviously for dates, blobs for arbitrary byte streams, and UUID for universally unique identifier. Now, in addition to these atomic types, there are 3 types of collections. List, which is a collection of one or more elements and order matters. Map, which is a group of key value pairs. And set, which is a collection of one or more elements with no duplicates and where order does not matter. Collections are useful when you want to keep multiple values in a single column. For example, you might want to change your app instance table to store the average, minimum, and maximum or priority over some period of time, such as the last 10 minutes. We can do this by specifying a collection called OS priority, in which we'll store 3 pairs, the string average, followed by the average value, the string minimum, followed by the minimum value, and maximum, followed by the maximum value.